Students, in this video we're going to look at proving another chord theorem, chord theorem 2. What this will involve, so after watching this video you should be able to prove that the chords of equal length are equidistant from the center. The things you'll need to recall are the parts of a circle, so first of all chords, how they go from one side of the circle to the other side of the circle, cutting it into two pieces, though not necessarily through the center. And equidistant means that for the chords of equal length that we're looking at, they should be the same distance from the center. As per usual with all of our geometric reasoning and deductive geometry questions, we need to remember our steps for geometric proof and how to set those out, and also the axioms and symbols that we use to justify our statements. Alright students, so in this proof what we're going to have to do is prove that the chords of equal length are equidistant from the center. So as with all our problems, we're going to label our chords. So we'll call this chord AB, and we'll call this chord CD. Now, what I'm going to do next is add in some construction lines, joining up our chords to the center. Imagine those both go to the center and that they're all straight. Perfect. Far from it, but you get the idea, students. Imagine they're straight, imagine they're going to the center. Now what I'm going to add in is the midpoint of each line. So let's say that this point here, we'll call it M, is the midpoint of AB, and up here we'll have N. We'll call that the midpoint of CD. Now when we talk about being equidistant, we mean our chord is going to be the same, each chord will be the same distance from the center. So what I'm going to do is draw a line from the center to our midpoint. And if our chords are equidistant, then that means these lengths from the center to the midpoint of each should be the same length, right? So the middle of our chord, that seems like a good place to find the distance from. So we'll go from the center to the middle of our chord, and if these chords are equidistant, then from the center O to our midpoint M, and from the center O to our midpoint N, those distances should be the same. And so that's what we're required to prove. So setting up our table, we've got our statements and our reason. Now first of all, we can say that CD and AB are the same length. So we know that because that information was given to us at the start of our problem. Our chords were of equal length. What we can also say is AO, BO, CO, and DO are all the same length because they are all radii of this same circle. Now what this means is that our triangles AOB and COD must be congruent by the SSS rule. All their sides are congruent, so our triangle is congruent, which we proved from lines 1 and 2. Now with that, we can actually say that some of our angles here, in particular OAM and OCN, must be equal because they correspond in our triangles. So OAN and OCN match up in our triangles, they correspond, so they must be equal in size. And based on the congruency we proved in step 3. Now we also know that AM and CN must be the same size because, first of all, some of that information was given. So we said M was the midpoint of AB and N was the midpoint of CD. We also said in step 1 that those chords were the same length. So if we cut them both in half, then the halves should also be the same length. That's the idea behind statement 5. Looking at that then, we've got new triangles, OCN and OAM, that are now congruent because of the SAS rule. So OC and OA are the same. We got that from step 2. Our angles are the same, OCN and OAM. We proved that in step 4. And the extra side, CN and AM, they are equal as well, that we proved in step 5 there. Now, if those triangles are equivalent, then it goes to show that corresponding sides are also equivalent. So OM and ON, corresponding sides, must also be equal based on the congruency we proved in step 6. That was what we set out to prove, so that proves our second angle theorem, QED. So after watching this video, you should be able to prove that chords of equal length are equidistant from the center.